In this video lesson, we'll continue our discussion in graphing inequalities, a review, and then bridging into something we call interval notation. So, we're looking at inequalities. We're going to learn how to write them in interval notation. The general format for interval notation, we have grouping symbols, either parentheses or brackets, which we saw in the previous lesson on the use of them, and two values. So it looks similar to an ordered pair, but not quite. So we'll start with an example where we've got x is less than -7. If we graph this on a number line, old school, would have first had the open circle, but we saw from the previous lesson, we can now simply use the parentheses to illustrate that we would not include the -7, and we would have included everything to the right of it, to the left of it, sorry. The deal is that in order to have the format of this interval notation, we need two values. So we input the two standard values on a number line, -infinity and +infinity. Here we can see that we would have shaded to the left and we would have included -infinity. So now we begin to see where the two values will come from in order to write an interval notation. So far, we've got the -infinity and the -7, and the -7 has the parentheses. So all we need is a corresponding grouping symbol in front. The corresponding grouping symbol will be parentheses, not because there's a parentheses here, but because of the meaning of parentheses. Parentheses is used when we do not include that particular value. Brackets is what we would use if we actually included the value. The idea is you could never actually be at -infinity. So you can just continue to approach it. So if we look at a couple others, you'll see the consistency. So x is greater than 4. If we graph it on a number line, there's our 4, and we would show to the right of 4, so we'll use an open parentheses. If we put in our two infinities, -infinity and +infinity, we would see that we would have shaded to the right, which we're going toward +infinity. So we can begin to create the interval notation, open parentheses 4, including the +infinity, and again, infinity will always use parentheses. So there's our interval notation. Next one, x is less than or equal to 9. So on our number line, there's our 9, and we would have put a bracket going toward the left, put in our two infinities, and we could see that we would have shaded to the left of 9, which would include -infinity. So we'll put what we initially have, the -infinity 9 and the closed bracket. Again, infinity will always have the parentheses. So you're not trying to match the two symbols. You're putting the symbol that's relative to the inclusion of that value. So the parentheses for the 4 because we did not include the 4. Bracket with the 9 because we will include the 9. Parentheses with the -infinity because you can never actually be at -infinity. Last example, x is greater than or equal to -1. Place our -1 on the number line. We'll have our bracket facing toward the right. Place our two infinities. We can obviously see it's going toward the +infinity. So as we begin to create the interval notation, open bracket, -1, +infinity, and again, infinity has parentheses. So these are all examples of taking a generic inequality and writing it in interval notation. Now I do want to share one mnemonic device to help you keep track of should you or should you not put parentheses with the infinity. So if I had a set of parentheses, I could actually include this to help make an infinity symbol. So the mnemonic device is infinity is actually made up of parentheses to help keep you focused that if you write infinity, you should include a parentheses. So now we'll segue to compound inequalities. In earlier grades, you were given two simple inequalities And with these two, you can put them together to create a compound inequality. In this case, one of the compound inequalities would be 5 is less than or equal to x, which is less than -7. Well, the first one in blue, you can see it right here. X is less than -7. The 5 is less than or equal to x is the actual second one backwards. If x is bigger than or equal to 5, 5 would be smaller than or equal to x. You were also taught that you could have written this in two separate ways, starting with the 5 or starting with the -7. So this is all stuff from previous lessons. So we're going to take this and do some old school and graph this. So there's our -7. We would have shaded it to the left in an open circle, and the 5 would have had a closed circle, shade outward. If I now transition this to the parentheses and brackets, again, this was called a disjunction, if you recall. We had two separate situations. Because they're going away from each other, this compound inequality was called a disjunction. So let's transition. Before we transition, let's look at a different one. Two separate simple inequalities. We create our compound inequality. This one I'm starting with the 1, ending with the 9. Could have written it backwards, starting with the 9, ending with the 1. Here, when we draw the 9 and the 1 in its correct place, the 1 would have had a closed circle, so would the 9, and we would have included everything in between the two numbers. This was called a conjunction. So you had two separate types of situations when you were working with compound inequalities. Now it's time to transition to the parentheses and brackets. So using the parentheses and brackets, at the -7, we would have had the parentheses going toward the left, and at the 5, we would have had a bracket going toward the right. So this is the graphing of this compound inequality using the parentheses or brackets. Same over here, the 1 and the 9, a bracket at the 1, and also a bracket at the 9. So this is just to illustrate compound inequalities using parentheses and brackets. So a few more examples. 6 is greater than x is greater than or equal to 0. I'm asking you to actually graph this. So my recommendation is to first put the emphasis, once you've got the two numbers, put the emphasis on the second half of the compound inequality. By doing this, this is telling you exactly what to do at the particular number. So this says at the 0, we'll put a bracket because of the equal sign, and the bracket will point to the right. There's our bracket. And 100% of the time in this context, the symbols will always go in opposite directions. Now, opposite doesn't mean away from each other. It means if one is going to the right, the other's going to the left. Look at over here. This one's going to the right. This one's going to the left. So, at the 0, it's going to the right. So, therefore, at the 6, goes to the left, leaving us with a conjunction. A few more samples. -4 is greater than x, greater than -1. If I identify -4 and 1, identify the second portion. So this is saying at the -1, I will put a parentheses going to the right. So if this symbol is going to the right, this one has to go to the left. And this will also be a parentheses. So in this case, we've created a disjunction. A couple more. In this inequality, put the numbers on the number line. Make sure we put it in numerical order so you're not following the numbers. -3 is on the left side of 2. Identify the portion I want to. This tells me at the -3, we're going to put a bracket going left. So the value at the 2 has to go to the right. One more. Of course, this is a disjunction. Put out numbers 7 and 9. Focusing on the end part. A bracket to the left at the 9. So if this is going to the left, going to the right at the 7, creating a conjunction. So now let's look at taking compound inequalities and writing them in interval notation. As we saw, there were two different types of compound inequalities. We'll first work with conjunction. So if we're writing it in interval notation, this is again the format. Some sort of grouping symbol and two values. So there's conjunctions. Here's the first conjunction we'll work with. We'll put the two values on the number line. Focus on the in portion. That is to say a bracket to the right of -2. So therefore at the 8 to the left. Now to write this in interval notation, it's basically taking the information straight off the number line. So open bracket, -2, 8, close parentheses. So this is the compound inequality written in interval notation. Another example, -5 less than x less than or equal to -1. Put our numbers on the number line, -5, -1. Focus in on the second portion. So at the -1, a bracket pointing left, which means the value here has to go to the right, parentheses to the right. Transition the information, open parentheses, -5, -1, close bracket. So interval notation, once you've graphed it, it's very easy to do. Disjunctions, a little bit more involved. Here's our first one, -8 greater than x greater than -3. Place the numbers on the number line. Focus in on the second half. So at the -3, parentheses to the right, which means the symbol here will go to the left, parentheses again. Now we can see there's our disjunction. The issue now is we need to write this in this format, in this interval notation format. Well, in order to do that, I'll have to show that I have two separate regions. So I'll go ahead and put in my infinities. So I can see here will be a separate interval from the one on the right. So my first one, -infinity to -8. The second one, -3 to +infinity. Again, you can see me using the parentheses for the infinities. There's one extra thing that one needs to do now to show that these two intervals are all part of the same solution, if you will. I'll use the symbol of a U for union. So this says this set and this interval all are part of the same solution. Another way of writing this, I can put my two interval notations, and I can put the conjunction or. So this is saying x is located either here or here. So either here or there. That's why we're using or. Another example, we'll place our values on the number line, focus in on the end. So to the left, a bracket, which means the parentheses, another bracket to the right. Add in our infinities, and now we can begin to transition to the interval notation. There's the first one, the second one, and like the other example, we'll combine it with the U. Or, after I have my two interval notations, I can then put or. So in the next portion, I'll go through a few examples.